everyone. This is Pavithra, Assistant Professor, Department of ECE, SNS College of Engineering. So in the last video, we have discussed about the K maps and all. In this video, we are going to discuss about the designing a sequential circuit. So in the last class, what we have discussed the flip flops, right? We were well known about the 4 flip flops. One is an SR flip flop, JK flip flop, D flip flop, and T flip flops. These are the flip flops we have discussed, and then in the last, and then another thing we have discussed the K map also, right? How to design, how to minimize the terms in the K map, right? So now we are going to see, already I have decided that this is a designing a sequential circuit, right? So what is a sequential circuit? Sequential circuit is nothing but it has a memory. It has a memory. When compared to the combinational circuit, the sequential circuit has a memory, right? We know very well. The sequential circuit has a memory, and what is the thing? Main thing is the output is taken as a feedback here. That what we have discussed in the sequential circuit, right? So if we don't have the memory, what will happen? We can store the data, right? So for that purpose only we came for the sequential circuit. The sequential circuit can store the data. We can set the 2 point. One is to store the data, another one the output taken as a output is taken as a input. Okay, the output that is taken as a feedback of the input, right? So this is a sequential circuit. So first of all, designing a sequential circuit. So we have 7 steps of designing a sequential circuit. First of all, first step is state diagram. So this is called a state diagram. So first step is called as a state diagram. I will explain you how to derive this one. So first of all, we will see the procedure. Okay, first one is a state diagram, and the second one is called a state table. So from this state diagram, we have taken the state table. Okay, so first step is state diagram, second step is state table, and what about the third step is nothing but assigning the binary value. See why we are going for this assigning the binary value? Because here the states are A, B, C, D. So our digital electronics is based on the binary value. So the step 3 is nothing but assigning the binary value. So so that is a step 3, and the step 4 is nothing but the excitation table. The excitation table is according to our flip flops. Okay, that is a step excitation table. That is the 4th step, and the 5th step is called a present state, and the 6th one is called a K map, and the 7th one is called as a designing of D flip flop. And how from this state diagram to the end of the circuit, designing of the circuit diagram. This is what we are going to discuss today. So the question, first of all, this is a problem. Designing a sequential circuit, we have to follow the following steps what I have discussed now. So first one is called as a state diagram. So in some question they will give directly the state diagram. In some questions they will not give the state diagram, right? So they will give the data alone. We have to draw the data diagram. Okay, so this is entirely different from what we have discussed in the last class and all. This is entirely different. Please listen carefully. First of all, this is called as a state diagram. So here how many states are there? 1, 2, 3, 4, 5. There are 5 states are there. Okay, the states are A, B, C, D, E. Okay, this is the states. So that's why it is called as a state diagram, and here it denotes the input and the output. So for example, for each state it have two things. One is 0 and another one is 1. So if the A has if we have the input as a 1, means the A will be the output as a 0. So for example, each state will have a 2 things. One is 0, another one is 1. So minimum there will be 2 states. The A will go with a 1 and A will go with a 0. The same thing, the B will go with a 0 and also 1. See, the B will go with a 0 and B will go with a 1. Again the C thing, C for the state 0. If the C is a 0, then output is a 0. If the C is 1, means the output will be a 1. Like that, each and every state have minimum two inputs, right? So for example, from this state diagram, we are going to take it in the state table. So state table. See, for example, step 2. This is the procedure for the state table. So how to write it in a state table means, first of all you have to write the state table present state. These A, B, C, D and all you have to take it in a present state. And we know whether, see here it is 0 and here it is 1. See, for each and every parameter we have a zeros and ones. So x is equal to 0, x is equal to 1. So this is the next state. So the output is x is equal to 0, x is equal to 1. So what I said before, the sequential circuit having a past input, right? So that is the present state and the next state. So x is equal to 0, x is equal to, these are the assumption. We have only the two states and the zeros and ones, and here output x is equal to 0, x is equal to 1. Okay, first of all, and we have to write it in the present state as A, B, C, D, E. Okay, A, B, C, D, E. So these are the states we have explained here. Now what is the thing is, see, the x is equal to 0. When x is equal to the A, when when what happened, if it is 0 means it's going to the B. So we are writing B here. Okay, so the A, when the input is 0 means it's going to the B and the state is 0. Okay, so that's what I have written here. Again, when the A is 1 means the output will be 0. Where it is going? C. It is going in a C, right? Okay, for first one I'm going to explain you. Please listen carefully. Here the A, we have zeros and ones, right? So for the 0, if it is 0 means where it is going? It's going to the B. So if A is equal to 0 means it's going to the B, right? If A is equal to C, if A is equal to 1 means the output is 0. So that's what I have written here, 0. And where it is going to the which state? It is C. So I have written C here. Okay, then again I am taking the second step. Second step, what happened? The A is going in the two states. See, this is a 1 and this is a 0. If the B is going in a 1, if I take a B, the B is equal to 0 means where it is a B, the B is equal to 0 means output will be 1. So 1, where it is going D. So I am putting D here. Again, the B is equal to 1, where it is going E. So E. So what happened when 1 is B is equal to 1, output is 0. So 0. Okay. Again for the C. C1, what happened? C, where is C? So C, the same state. Okay. So Z goes in the same state. So C is equal to C. The output is 0. So 0. Okay. And then